Hi guys, welcome back to my YouTube channel. Guys, let's do this question, and I first of all read it. Evaluate the integral using polar coordinates. Before guys we do that question, maybe I could just demonstrate to you something for a short time. Guys, we have here something whereby this one is a diagram of how we could convert the polar coordinate to Cartesian coordinate. Guys, as you can see, we have the dA, which is subtended along the R, that is along the radius, and we have this one which is subtended along the y-axis. So guys, the area for this is supposed to be r d theta, and this is what we call the polar form. For the Cartesian form, we have this one, which is the area for the element is dx and dy. And then guys, we can be able now to say that our y, according to the polar coordinates, is r sine theta, and our x is equals to r cos theta. And here we have the degrees that our element is from this point. And then that element runs from this point, that is 0, up to the radius. And then we can be able now to run that element along the circumference. And we have this one which is for the Cartesian, which we can run along the y-axis and then along the x-axis. So guys, we shall be using this diagram for that purpose. And so let's start our question, guys, and see. So the first thing, guys, we are going to draw is what we call a domain diagram. And the domain diagram is right here. I've already drawn the domain diagram for that. So guys, mine is now to change into Cartesian form. And this is how I will do it, guys. I'll come and draw the integral. Let me just draw the integral right here, guys. The first integral and the second one. So guys, I will now say for the first integral, we have our element should run from this point, that is r equals to 0, up to r equals to, according to us, is r equals to 2, because here we have r for this is equals to 2. So the element will run from this point, r equals to 0, to r equals to 2, just as I have shown here, guys, from this point up to that point. So this is r equals to 0 up to r equals to 2. And then guys, our element should run now from this point, that is at 0 degrees, up to this point, which is pi over 2. That is from this point, that is along the circumference. Along that circumference, the strip is going to run along that until it comes here. And remember, guys, this is the domain. So it's not that area we are looking for is this area. No, we are looking for an area within that domain. And so we have now that will now run from degrees, that is 0 degrees, to pi over 2, like that. So guys, again I say that this is just the domain, and the area is within that domain. So from there, guys, we come and now check this, whereby now we have been able to establish the polar coordinates. Now we can come and convert r. We have, first of all, we have x is equals to r cos theta, we have y is equals to r sine theta. So guys, we can come and replace these ones. X is r cos theta, like that. The y is supposed to be r, so I can put square and then sine theta, like that. And then guys, we continue. We have all over. This one is now going to give us square root of this now squared, x squared, y squared. This is r squared. Then we have here cos squared theta plus sine squared theta, like that. And then guys, we are going to convert the dx to d and dy into polar form, just as we have shown here, that our dA in Cartesian form is dx and dy, but in the polar form is r dr d theta. So this is going to be r dr d theta, like that. So that's what we are going to have. So guys, we now come and do that question. So let's do that question. So this is going to be, here we have 0 pi over 2. We have again 0 to 2. Then here guys, we can say for this one guys, this is going to be 1 according to the trigonometry. Then we are left with r squared, and square root for that is r. Over here guys, we have r squared. Then we have cos theta, sine theta. So that now this r is going to cancel that r. This can cancel that r. Then we are left with dr d theta, like that. So guys, what we do now, we come and integrate. First, with respect to dr, whereby the element is moving from r equals to 0 to r equals to 2. So I start with that one. So now it's going to be 0 to 2. Then I have r squared cos theta sine theta, and then here we have the dr, like that. So after that guys, we come and now integrate that. So if you integrate that with respect to r, this is going to be constant. So you have cos theta sine theta, and then r we integrate, going to be r cubed all over 3, like that. So now guys, this is now going to be cos theta. If we put this is 0 and 2, guys, if we put 2 there, we are going to get 8 over 3. So then now guys, we integrate yet again with respect to now pi 0 to is from now 0 to pi over 2, 0 to pi over 2, and now we have r cubed. R cubed already guys, we have done. So we are left with the cos theta sine theta, and then here we have now the d theta. This is now the d theta we have here. So we put d theta. So let u be equal to sine theta. So du d theta is equals to cos theta. And so therefore guys, we are going to have du all over cos theta is equals to d theta. And so therefore, guys, we are going now to replace for d theta here. So we shall have integral from 0 to pi all over 2. We put cos theta there. Then sine theta, this is going to be u now. Then instead of d theta, we have du all over cos theta. And guys, we have 8 over 3 there. So this one, guys, is going to give us 8 over 3 this is going to cancel. So guys, we are now going to be left with u. You integrate that, you'll get that from 0 to pi all over 2. So guys, when you do that, you get 8 over 3. You can return that u to sine. So this is going to be sine u equals to sine theta. So you shall get sine theta squared like that all over 2. So this one too, you bring it here like that. So when you put 0, it should be 0. When you put pi over 2, you shall get now 1. So this one is going to be 1 like that, and then 8 all over 6. So this one, guys, is going to give us by 2 3 by 2 4. So this is 4 over 3. So guys, this is our solution. Thank you for listening to me. Bye bye.